Hi there, I'm Harv, and this is just another video of me solving randomly code problem. So we have to find the first missing positive today. We need to do it in ON time and O1 space, right? And A1 is to be the smallest positive integer, right? So if it is the smallest positive integer, it has to be 1, right? 1 is the smallest positive integer, and we can count up, right? So because they want the smallest positive integer. So the missing positive integer will always be between 1 and then the length, right? Plus 1, right? That's why if the length is 4, right, then the maximum we can store is 1, 2, 3, and 4, right? We have to count up, right? Because they want the smallest positive integer. So the missing the missing integer is gonna be 5, right? Which is length plus 1. It can be 4, right? It can be 2, right? So on and so forth. So we know that the missing integer, right? So smallest missing positive integer, right? Gonna be between 1 and the length, right? Plus 1. Okay. So um we can use the index, right? Because we want to do it in O1 space. So we have to save space here. So we can use the index. Right? We can use the index to represent the number visited, right? We can use number 1 to represent 1, right? By setting the value at the next one to be negative. We don't care what the value is, right? We only care about the sign, right? If it is negative, negative, right? So use negative, right, to mark uh, visited, right? Right. So if it is negative, which means it's already visited, right? If it is positive, which means it is a missing integer. Okay, so we can use the index here to represent 1, 2, and 3, right? And because we don't use we don't use integer 0, the smallest integer, the smallest positive integer gonna be 0, and that gonna be 1. So we can use index 0 here to represent number 4, right? We can use it to represent the length, actually, the length. So if the length is 4, uh it's gonna represent 4, right? And then what we have, length plus 1 number, right? We have length plus 1 number. So we can represent the number from 1 to the length, right? And then at the end, if none of the integer, right? If none of the value at both index, right, are negative, are positive, which means all of them has been visited, right? Negative, 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 right? Everything is negative here, right? Which means that the next missing positive must be length plus 1, which is 5, right? If all of them are negative, which means they are already being visited, right? Right, 1, 2, 3, 4. So then the next smallest has to be 5, which is length plus 1, right? So we have just enough space to represent our we have just enough space to represent our numbers here, right? We have 1 from 1 to length plus 1. Then we can represent from 1 to length, and the length plus 1 we're just going to be the remaining case, right? Okay. So the question is, what number can we use to represent um the value here? So because we are using the number, right, at the index, right? So for example, right, if we see the number 2 here, right, which means that we can go to index 2 and set the value here as a negative, so that we don't care about the value at 2, right? We only care about the side. If it is number 2, we're gonna go to index 2 to set the value at index 2 to be negative, to mark it as visited, right? But what if we have a negative number, or a number that is equal to the length, right? Because we only have the index from 0 to length minus 1. Right? What if the number negative or equal to the length? Right? Well, so if the number is equal to the length minus 1, sorry, if the number is equal to the length, right? If it is 4, for example, if we are at index 2, right? We read, okay, this is number 4, right? We have to go to index 4 to set the value at index 4 to be negative, right? But we don't have index 4. So as I said earlier, we can use index 0 to represent the length, to represent the length, okay? So we can set the value at this index to be negative to represent the length, right? The length number, the number of the length, the number equal to the length, right? Okay, so what if we have a number that is larger than the length, right? Length plus 1, so larger than the length, right? Or less than or equal to 0. Is okay. What should we do? Because we don't have the index, right? We use the length index to we use index 0 to represent the length, right? But what if it is even larger than the length, right? Like 1,000 or less than or equal to 0. So in that case, we need to iterate through the array first and get rid of those number, right? So how can we get rid of those number? We get rid of those number by giving it a default value, right? A placeholder value. And then the placeholder value must be a positive integer, right? Right? Because if we use negative, then we're not gonna have the index. It has to be a positive integer in the range, right? From 1 to length, right? So what number should we use? We can use the smallest integer 1. But if we use 1, right, then we need to make sure that 1 doesn't exist, right? Sorry, we need to make sure that 1 is already exists in our array. Because if 1 doesn't exist, then the smallest missing positive integer are going to be 1, right? So we need to make sure, right? Make sure 1, right, not exist, not exist, right? If 1 exists, right? If 1 exists, we're gonna return 1, right? At the smallest missing positive. Yeah, 1. Okay, and then so if 1 exists, right? Sorry, this one is if 1 uh doesn't exist, right? If 1 does not exist, right? So if 1 is not exist, right, then we can return 1, right? So if 1 exists, right, so we don't care because 1 is already exists. So it has to be the missing part, it must be another element, right? So we can use 1, right? Use 1 as the placeholder, right? To get rid of any element that is less than or equal to 0, or right, or and then greater than the length, right? Because those number we don't have the index to represent, right? So we need to get rid of them by setting the value at those index to be 1. Okay, right? So we're gonna have a bunch of 1 here, right? It doesn't matter, right? We just have to go to index 1 and set it to be a negative number. When we don't care because we know that 1 is already exists, right? So setting it to be negative again doesn't hurt us, right? Okay, and then we can. So after we do that, right? Now we are ready. We know that 1 doesn't exist in our array, so we can use 1, right? In our array right now, we know that the values gonna be between 1 and length, right? The value in our array now we always between 1 and length, right? We use index 0 to represent the length. We use the remaining index to represent the number, right? So we can iterate over those number, right? If it is number 1, we go to if it is number 2, we go to index 2 and set the value at index 2 to be negative. So you can use negative, right, sign to mark integer, right, as visited, right? And the last step, we need to iterate from 1 to the lines, right? Right, and then we can return, right, the first positive integer, right, in our array, okay? Because the positive integer is the integer that hasn't been visited, right? All right, so let's look at an example here. If we have 1, 2, 3, and 4, right? So the number gonna be between 1 and 5, right? This is our index. Let's try a different something different. So do -3 and then 10 here, right? So the first step, right? We need to iterate through. We need to iterate through the array, right? Make sure the number 1 doesn't exist. Oh, sorry. Make sure the number 1 exists, right? Okay. If the 1 doesn't exist, let's say this is 3, right? If the 1 doesn't exist, we can return 1, and we are done. And that is the first case, right? So if the 1 exists, which means, okay, we are set. We can use number 1 as the placeholder, right? Okay, so we iterate over the numbers, right? Checking if it is in the range or no. So let's say this is 6, right? Just enough to be out of bound, right? It can be 5, right? So 1 is good, right? Because we have index 1. Okay, 5 is good. Oh, sorry, 5 is sorry, should be 4. Sorry. Should be 4. This should be 5. Right. Okay. So 1 is good. We have index 1 represented. 4 is good, right? Because 4 is equal to the length, right? So you can use index 0 to represent the length. So that is okay, right? -3 is not okay because we don't have index -3. So we turn it into a 1, right? 1 already exists, so we don't care, right? 5 is out of bound, right? Because we don't have index 5. So we set this to 1. Okay. So yes, we finished step 2 here. Now we are in step 3. We need to use the negative sign to mark the integer visited. So we're gonna iterate for each number. So 1 here, right? We go to index 1, right? Set the value at index 1 to be negative. So we always look at the absolute value, by the way. So this is 4, right? So we go to index 0 to set the value at index 0 to be negative, right? Index 0 represent the length. Okay. So 1, right? We go to index 1 again to set negative. We already did that. Same for here. So now we are done, right? So now we just have to iterate from 1 to 3 again. Sorry, 1, 2 to 3, right? So 1 to the length -1. Right? So okay. Mm. Yeah, so we can just iterate through an array again, right? So if the number here is 0, right, is positive, we're gonna return the length, right? If the number here is positive, we're gonna return index in 1, right? Number 1. If it is positive, we're gonna return 2, right? So in this case, the value at index 2 is positive, which means the first missing, which means the smallest missing integer is gonna be 2. So we return 2. Right. Let's say, for example, right? Let's say, for example, we have 2 and 3 here. Right. So if we iterate through the whole thing and everything is negative, then we return 5, which is like plus 1. Right. And yeah, that's pretty much it. Okay, and yeah, we can combine these two steps together, right? We need to use two for loop. We can set a flag, after the loop. If we cannot find the one, we can just return one, right? These two steps can be combined into one loop. It's gonna save us some time there. So yeah, let's code this up. So the first step is to let's create some variable here in the long, right? So we need to return one, right? If one is not 5, right? So let's do this. So let's say if one exists, use one as placeholder, right? Otherwise, return one. Okay. Otherwise, mean one doesn't exist, right? So we can set a flag here that has one, right, equal to false, right? And then we can check if one doesn't exist, we can return one, right? Okay. Okay. So if number I is equal to one, then we need to set the has one, right, to be true. If one exists, then we are set, right? We can use it as a place holder. If one doesn't exist, we can return one at the end here. Right? And we want to get rid of the numbers that is less than 0, less than or equal to 0, right? Because we don't have negative index, right? And we also don't want to use a 0, right? Or number I is greater than n. You can set number I is equal to 1, right? Because we can only represent index, we can only represent the number from 1 to n, right? Where index 0 represent n. So anything that is out of range, right? Less than or equal to 0 or greater than n, just set it to 1. Okay. So yeah, after the while loop, the for loop, right? We already set the placeholder, right? Assuming one doesn't one exists. So if one exists, we can just return one and finish. Okay. And then next thing we have to do is we need to set. So now we are ready to set negative, right? We can set the negative, uh, right? Index, right, to represent positive integer, right? And then set negative, set value at index, set negative value at index, right? Negative value and index to represent to mark bigger bit. We will look at the number. We only look at the absolute value, right? Okay, number 5 yeah. So if num is equal to n, right, we're gonna set the nums at 0. We can use index 0, right, to represent the length number equal to 1. Okay, so we always have to make sure that this is a negative number, right? So we always do the what if number 0 is already negative, right? If we multiply by negative 1 again, it's gonna become a positive. So we need to make sure that it is a negative number, right, by using the axiom and then multiply by negative 1. Okay. Um. Yeah. So if it is not if num is not equal to n, right, which means it has to be between 1 and n minus 1, right? So in that case, we can just use num as the index is equal to map of f of num. because num because we know the num here num is between 1 and n minus 1, right? We can just index into, we can use the number as the index, right? Because we use the index to represent the visited integer, right? You can just mark the value as negative here. And yeah, that's pretty much it for that step, right? So this is the first three step, right? This is step 1 and step 2. We combine. This is the step 3, right? The last step is just to return the first, right? Missing positive integer, right? And we can return n plus 1 at the end, right? We couldn't find it. So let I equal to 0, I sorry, equal to 1, right? Because we don't, oh yeah, 0, because we use index 0 to represent the n, remember? Right, so if num of I, right, if num of I is greater than 0, right, then we can return something, right? We can so if n is equal to, so if I is 0, right, we can return n, right? Otherwise we will return I. Okay, so yeah, we use index 0 to n, right? We use the index to represent the integer, right? So if it is so if the value at index 1, 2, 3, 4, right, uh or positive, which means that is the first missing positive, because we mark visited as negative, right? And then yeah, we know that 1 is not the result, because if 1 is the missing, we already returned here. So we're just gonna iterate with the loop for the sake of completeness, right? If the index is 0, which means then right, if the index is 0 and the value at index 0 is gonna be positive, you know that the missing integer is gonna be n, right? Because we use index 0 again to represent n. So if we couldn't find any positive integer in the array, right, which means the missing positive has to be n plus 1. Okay, let's see what's wrong here. So for oh yes, we need to iterate up to n, right? Wait, is it? No, no, not really. It's just 0 to n minus 1. That's weird. Um, let's see. Let's cancel off our nums here to see if we have the correct array. Right, 3, 4, 1, 1. Because 1 already exists, so we set this one to 1. Right. And what is our nums array? After step 3, we have so negative 4, which is 1, right? 1 is visited. And then wait, somehow we have an extra element here. We shouldn't have an extra element, right? We only go from 0 to, oh, right here. Num, not nums, right? Num is right. We have to check the num. If num is equal to n, right, which means we can use index 0 to represent that. Yep, now it's accepted. Just a typo there. Run again. Submit. Okay. Okay, let's take a look at this case. Run. Okay, it should be 13 here. 3, 6, 9, 12, 13, 14. It is returning 14. Yeah, this is index 13, right? Yeah, it's also here 13, 14. How can 14 be positive? So how can index 0 be positive when we don't have number 14 here, right? So the length of the whole array is for 14 when we use index 0 to represent index 0 to represent the oh, okay, I see. So okay, so we are both missing 13 and 14, right? We are both missing 13 and 14, right? 14 is the first index here, right? And 13 is the last index here, right? Because we index 0 to represent the length. And we want the smallest positive integer, the smallest one. So we need to check index 0 last. We need to check index 0 last, right? So we need to start from index 2 here, right? And then we can just return I, right? So we have to, because we know 1 is not the answer, right? Because if it is 1, we already return here, right? If 1 doesn't exist. So we start from index 2, right? And we have to check index 0, the last one, because we want the first, the smallest one, right? Index 0 gonna represent the length, which is larger than n plus 1, n minus 1, right? So, and then we can return at the end here, if we can check if numbers of 0 is greater than 0, right? If it is, we return n, and otherwise we return n plus 1. Okay, it should work now. And thank you for watching.